Welcome to Next Gen Chemical and Petrochemical Summit 2024. And thank you so much, Mr. Praveen, to have a nice introduction, which is provided by me earlier. And dignitaries on the dais and all the delegates who have gathered here to make India transforming to global manufacturing hub and make India 5 trillion economy in 2027. So I would like to start my presentation. First of all, safety is our top priority. Emergency exit is on the right side. You have a staircase. You can just move quietly to the ground floor at your assembly point. Use protective equipments while traveling on the road. Use helmet and seat belts because somebody is waiting at your home. So I would like to start my presentation for solidification through steel belt cooling technology. Just to talk about the history of steel belt, we have started since 1901, which is 124 years back, making world's first steel belt process conveyor. And now we are having the world's best steel conveyor for the process. Key segments in which steel belt cooling technology can be used is chemical solidification, sulfur solidification, film casting, composites, food, and many more. And the applications which we can use through is double bed pressing system for wood-based panels, rubber belts and all, scattering for building materials, pastillation for chemicals, sulfur, film casting for making thin films of polyurethanes and battery separators and everything, extrusion for powder paint, drum granulation for sulfur, and cooling, of course, for many chemicals. So different industries, we are working with chemicals, cosmetics, digital printing, battery technology, food, pharma, powder paint, building materials, and wood-based panels, and of course chocolate. So just talking about some technical things for chemical solidification. We have pastillation technology, which is used for making pastils of different chemicals. If you can see the process, there is a raw material coming from reactor to our rotoform system through pump, and it rotates, makes droplets onto the steel belt. There is a cooling water spray at the bottom of the belt, which solidifies the whole chemicals and make the pastils at the end, and it's scrapped and bagged and moved to the further transportation. So if you see the principle of rotoform pastillation, how the pastils are made. So if you can see, there is a stator in which the heating coil is there, through which the liquid comes, and it is kept on liquid state through heating. It will not solidify here, because if it solidify here, it doesn't mean anything. And the rotating shell, which rotates continuously, and there is a one component called metering bar, which meters the flow of the liquid through the stator. And when the holes of the rotor and metering bar coincide, the droplet is formed. And it is transferred through the steel belt, which is cooled down eventually along the length. The other technology is flaking. Some of the materials cannot be pastiled, which is having low viscosity, which is flowing easily. So they are used with the help of they are solidified with the help of flaking. So we have double belt flaking and single belt flaking based on the nature of the product. So principle is same. The material is flown in between two steel belts. There is a flooding of the water on top of the steel belt, and at the bottom of the steel belt there is a cooling water spray. Eventually from the both sides the material gets solidified, and at the end the sheet is made and it is braked with the help of breaker. So in case of very amorphous kind of material like resins and pitch and all, they are solidified with the help of this technology. And there is a continuous water flowing in circulation, so there is no wastage of water. It is a closed loop circuit which is collected back into the tank or pit and passed again through the heat exchanger and again sprayed into the equipment back. So if you remove the upper part of the belt, there is a single belt. The chemicals which can be solidified easily, we can have a single bed technology for cooling. So if you see how the cooling is done, there is a steel belt on which at the bottom of the steel belt there are cooling water spray, and it is sprayed, collected back, the hot water is collected back, and it is flown through the gravity to the pit or tank, and again it's pumped back to the system. Coming to next, which is a very interesting film casting technology. So through steel belt we can make very thin film with the help of feeding device, which is used in different applications like making filter membranes, very thin membranes which are used in vaccine filtration, which is having around 10 micron to 50 micron thickness. For we can use it in LCD or our mobile screen film, which is having 100 micron or 200 micron thickness. Also, it is used as a battery separators, making a battery separator, the polyamide resins, and it is having around 100 micron thickness. So very precise equipment and very precise films. We can make it through this film casting machine. You can see some of the pictures, how it is used. So applications, manufacturing of thin films for LCD, LED, OLED, fuel cell separators, filter membranes, pharmaceutical applications like drugs, patches, and medical films, and water soluble films for packaging. Some of the type of films, which is polyamide, cellulose, trisilicate, we call it TAC, PC film, POVH film, filter membrane film, ceramic tapes used for semiconductors, and edible films, which we can eat as well here. This is just a principle how the film is made. It is a continuously running steel belt. We have material passes through the steel belt. There is a venturi dryer which eventually suck the solvent through filter membrane, which is having acting like a NRV. So the solvent which is sucked through the venturi action will not come back, and it is passing and carried over with the help of air. There is a picture of our very precise feeding device having a tolerance of microns. Also powder paint technology, we are into the solidification of extrusion and powder paint, where we can, the powder paint is basically nowadays very popular. It is having many advantages, like they are less pollutant, they are having recycling capabilities, they can use the 100% theoretically, because if you see, the sprayed powder can be collected back. If it is unused, we can again use it, recycle it and use it again. So theoretically it is 100% possible to use for the coating. Also it is non-hazardous and having zero volatile organic chemicals, VOCs, so it is also environment friendly. So nowadays it is becoming very much popular for building industries. This is just a small picture of our powder paint. The solid surface which are used for making this solid boards, MDF boards or something. Yeah. So artificial marble and MDF boards and all, they are having a market growing with the help with the 8% of at least almost rate. China is of course leading in this, and they are more than 50% in this market, but India is also eventually growing in this. So this is just a picture how the double bed press system works for this artificial marble and all. So there are heatings, cooling chambers in that, and eventually it is passed through double bed press system, and at the end it is cut and stacked and transported to the market. So thank you so much for your time.